We're based on a few core principles that help it efficiently update and render user interfaces. Let's break down how React works. 1. Component-based architecture. React applications are built using components, which are reusable, self-contained units of code that define how a part of the user interface should appear and behave. Components can be functional or class-based. Functional components. These are stateless components that are simply JavaScript functions returning JSX. Class components. These were used for state management before React hooks and are built using ES6 classes. Each component can have its own state, internal data, and props, data passed from a parent component. 2. JSX, JavaScript XML. React uses a syntax extension called JSX which allows you to write HTML-like code inside your JavaScript. This makes it easier to define UI elements directly in the code. Example: const element equals h1 hello, world, /h1. Although JSX looks like HTML, it gets transpiled into JavaScript functions, using React.createElement. 3. Virtual DOM. One of the key innovations of React is the virtual DOM. When you create a React component, React doesn't directly manipulate the browser's DOM. Instead, it maintains a lightweight representation of the DOM in memory, called the virtual DOM. When a component's state or props change, React re-renders the virtual DOM for that component. React compares the virtual DOM with the previous version of the virtual DOM using a process called reconciliation. This allows React to identify the differences, or diff, between the two versions. React then efficiently updates only the parts of the actual DOM that need to be changed, rather than re-rendering the entire page. This makes updates fast and minimizes performance hits. 4. Unidirectional data flow. React follows a unidirectional data flow. This means that data in React always flows from the parent component to the child component through props. This is known as top-down or unidirectional data flow. State. Each component can maintain its own internal state. When the state of a component changes, React automatically re-renders that component and updates the DOM accordingly. Props. Props are read-only and passed from parent components to child components. They allow data to be passed down the component hierarchy. Since data flows in a single direction, it becomes easier to reason about your application and debug issues. 5. React hooks, functional components with state and lifecycle methods. In modern React, hooks are a crucial feature that allows functional components to manage state and lifecycle events. Previously, class components were needed to handle state and lifecycle methods, but hooks provide a simpler, more flexible way to do this in functional components. UseState allows you to add state to functional components. UseEffect allows you to manage side effects, example fetching data from an API, handling subscriptions. UseContext enables sharing of state across multiple components without passing props down manually. Example of using hooks. Import React, UseState, UseEffect from React. Function counter. Const count, setCount equals UseState, 0. UseEffect, equals. Document.title equals you clicked $count times. Count. Return. Div. P you clicked count times /p. Button on click equals set count, count plus 1. Click me. /button. /div. 6. React reconciliation. React uses an efficient algorithm called reconciliation to decide which parts of the actual DOM need updating after the state or props of a component change. React compares the new virtual DOM with the previous version. It calculates the minimum number of changes required to update the real DOM to match the new virtual DOM. Only the elements that have changed are updated in the real DOM, which makes React very fast for rendering updates. 7. Declarative programming. React encourages declarative programming. This means that instead of describing how the UI should change, imperative programming, you describe what the UI should look like for a given state. React takes care of updating the UI automatically when the state changes. For example, const greeting equals is logged in equals return is logged in h1 welcome back /h1 h1 please sign up /h1. 8. Component lifecycle. React components go through several lifecycle stages. Mounting, when the component is first added to the DOM, example component did mount, for class components or use effect in functional components. Updating, when the component's props or state changes, triggering a re-render. Unmounting, when the component is removed from the DOM, example component will unmount. Summary of how React works. Components define reusable UI elements. JSX enables HTML-like syntax in JavaScript. Virtual DOM improves performance by minimizing actual DOM manipulation. Unidirectional data flow simplifies state management. Hooks bring state and side effects to functional components. Reconciliation efficiently updates only changed parts of the DOM. Declarative programming simplifies UI updates by focusing on what rather than how.